Hi everyone, we're going to use the principle of mathematical induction to prove that 4 raised to the n power, then minus 1 is divisible by 3 for all positive integers n. So we'll get started, and I have some few steps outlined here. We're going to write out a conjecture for s sub n. It doesn't represent a sum, but we're going to say this represents a conjecture. So our conjecture is, since using the definition of divisibility, we can state it as follows. We can say s sub n is 4 to the n power minus 1 equals 3r, and that's for some integer r. So some integer r. This means there exists. All right. Since we have that, we have to verify first that it works for n equals 1. So we're going to first verify that it's valid. And we get 4 raised to the first power minus 1 equals 3. And 3 is divisible by 3, so our conjecture is valid or true for n equal 1. Next we want to do is assume that s sub k is true and prove that s sub k plus 1 follows. So s sub k would be 4 to the k power minus 1 equals 3r, and that's for some r that's an integer. All right, and then it follows that s sub k works, so k plus 1. Now this time we're going to change it, because this r goes with some integer with s sub k, but we're going to use, say, t for some integer for this one, because these two are different. So just change that up. So I'm going to write this out again. We have s sub k equals 4 to the k power minus 1 for some r, some integer r, and then s sub k plus 1 equals 4 to the k plus 1 power minus 1, and that should be divisible by some integer here, t. All right, now to prove this, what we want to do is look at this one and make it look like this one, because we want to show that it follows. So basically what I'm going to do is I'm going to take this original one here and multiply through by 4. So I'm going to have 4 times 4 to the little k minus 1 equals 4 times 3. Now this equals 4 to the first power times 4k minus 4 equals 12. Simplifying this, I'm using my product rule. This is 1 plus k. My base is 4. So this is a 4 to the k plus 1 minus 4. There should be a t here. Equals 12t. Again, I want this to look like this one. So what I'm going to do is add 3 to both sides. When you get that, you get 4 to the k plus 1 minus 1, which is what we wanted, equals, and on this side, what I'm going to do is factor out a 3. So you get 4, actually this should be r's, so sorry. So 4r plus 1. Now what we're going to do, and this is why we have the t here, we're going to let 4r plus 1 equal t. So what I have left, and that t is integer. So what I have left is 4 to the k plus 1 minus 1 equals 3t, and now it matches up. And we have proved it. Thank you. Have a nice day. Bye-bye.